This is going to be a fun problem. All right, so let's do number 56. The determined coyote is out once more in a pursuit of the elusive roadrunner. The coyote wears a pair of Acme jet-powered roller skates, which provided a constant horizontal acceleration at 50 meters per second. All right. The coyote starts at rest 70 meters from the brink of the cliff the instant the roadrunner zips past the direction. So let's kind of draw this. And I won't be able to draw this that well, but I'm going to kind of do my best. So the roadrunner is going to pass right the coyote and or actually, let's keep reading this. No, actually, let's just start this. So we know that this is going to be 70 meters. We know that this object, this coyote, is going to have an acceleration of 15 meters per second square. So let's find the time it takes. Actually, let's see what they're asking. Assume the roadrunner moves with a constant speed. Determine the minimum speed it must have to reach the cliff before the coyote. At the edge of the cliff, the roadrunner escapes by making a sudden turn, while the coyote continues straight ahead. The coyote skates remain horizontal and continues to operate while the coyote is in flight. So its acceleration while it's in the air is going to be 15 meters per second square in the I-hat direction minus 9.8 meters per second square in the J-hat direction. So that's basically going to look like a straight line. So let's solve for this. So let's find the time it takes for the coyote to reach this point at 70 meters. Because that would be the minimum speed that this roadrunner would have to run fast at. So let's find that. Let's find the time it takes. So in order to do that, we're going to let the output be 70 meters. And we're going to let the acceleration, which is going to be 15 meters per second squared, divided by 2 times t squared. And that t, 70 times 2 divided by 15, square root that thing. So that t is going to be 3.05 seconds, or 6 seconds if you want to round it there. It doesn't really matter. So I'm going to store that in my calculator. So I'm going to take 70 meters divided by 3.05 seconds. And I usually store everything in my calculator. So, all right, so let's answer part A. So the minimum speed of the roadrunner would have to be, according to this, 22.91 meters per second. All right, so that's part A. Let's see what part B is asking. The cliff is 100 meters above the flat floor of canyon. Determine where the coyote lands. All right, so let's find the time it takes for the coyote, starting at some initial velocity at 0 in the y component, to land at 0. So the output is going to be 0. That's just going to be 9.8 meters per second square times the t. Let's find that time it takes. So this is going to be t1. I'm going to call that t2. And what the heck did I do? Oh, honestly, folks, I didn't write any notes when I did this problem, so I'm just kind of like resolving this. Because I mean, you know, if they're really hard, I do tend to, you know, solve them, but if they're not, I tend to ignore it. All right, so the time it takes to get to this point, after 3.05 seconds is going to be 4.51 or 52 seconds. So that's the time it takes for the coyote to hit the ground at 100 meters above the ground. So, and the reason why I'm going to use that is because I am going to take 15 meters per second square. I'm going to find the whole total time it takes, which is 3 point whatever the fuck seconds. Let me see. 3 seconds plus that seconds. So I'm going to cheat a little here because I'm a bit lazy right now. But I'm going to take the whole time interval of 7.57 seconds. And I'm going to take that. I'm I'm going to take that 15 meters per second square divided by 2. That way I don't have to take the initial velocity into account. Because fuck that. And I'm going to take 5.7 seconds square. So I'm going to take that, so I'm going to take 15 divided by half. So 15 divided by 2 times that thing square. The whole total distance would be 430 meters. So I ended up getting 430.08 meters. Now, keep in mind, folks, I am not blindly like putting numbers. Make sure you read the math, because what I actually found is the whole total distance. So I'm going to have to take minus 70 difference into account to get this whole distance, which is going to be 360.08 meters. And yes, I did just calculate this just now. So the whole distance that this would travel, so the coyote lands in the canyon at X being 360.08 meters, if you want to round that far. 38 meters. All right, so let's answer for part C. Determine the components of the coyote's impact velocity. All right. Oh my God, I really just want to get the solution manual out of the way. All right, so let's find the impact velocity of the coyote. We know the time it takes for it to hit the ground. Let's find the horizontal velocity of the component. So let's find that. So let's say that it takes 7.57. I'm just going to multiply by 15. So the horizontal component Vx here is going to be 103.59 meters per second. And the Vy, which was what was that? That was like 4.5 whatever the heck seconds. Times 9.8. So Vy here is going to be 44.27 meters. So that's going to be, so this whole thing is going to be the Pythagorean theorem. It says impact velocity. I think I'm just going to write it in terms of the components. So the velocity here is really just going to be, actually, I'm 113.59 meters and 44.27 meters per second. All right, we're done. All right, guys.